All right, so here we go. We're going to look at some of these problems and just figure out what to do with them. So remembering that, hang on, let me write this down. What we have then is, this is hard. Oh my goodness. Okay. Whatever. Okay, so what I have is, let f of x equal x minus 2. So f of x is going to equal x minus 2. And then g of x is going to equal x squared minus x. Okay, it says, please find f plus g of negative 2. Okay, so first of all, what am I supposed to do? What that literally means is to take f of negative 2 and add it to g of negative 2. So I'm going to substitute negative 2 into here and negative 2 into here, and then I'm going to add it up. Do not multiply your answer by negative 2. That is not what it says to do. So looking at this, I have f of negative 2 is going to be negative 2 minus 2, because that's your x value right there, plus, and then I have negative 2 squared minus negative 2. Okay, so there's your negative 2 squared minus negative 2. So when I clean this up, a negative 2 minus 2 is a negative 4 plus, and then that becomes a 4 plus 2. So negative 4 plus 6 is going to be 2. So your answer is 2. So remember, do not multiply that by negative 2. All this is a shortcut to saying take f of negative 2 and add it to g of negative 2. So now we have, given that f of x is 3x squared plus 4, okay, so I've got f of x, I'm not going to bother trying to zoom in, f of x is 3x squared plus 4, and g of x is negative 2x plus 1. What I would like to do is find f minus g at negative 4. So remember, what does that mean? That means f of negative 4 minus g of negative 4. It does not mean times negative 4. So I'm going to substitute in a negative 4 into here. So I get 3 times negative 4 squared plus 4. And then I'm going to subtract. I'm going to shove, let's use a different color. I'm going to shove negative 4 in here. So negative 2 times negative 4 plus 1. Okay, so let's do this math. Negative 4 squared is 16. So I get 3 times 16 plus 4 minus 8 plus 1. Okay, so 3 times 16 is 48 plus 4 minus 8 plus 1 is 9. So I get 52 minus 9 is going to be 43. So 52 minus 9 is 53. Do not multiply that answer by negative 4. Okay, so let's do another one. I've got f times g at negative 2. F times g at negative 2. So what that literally says is f times g at negative 2 means f of negative 2 times g of negative 2. So if f of x is x squared minus 19, and if g of x is 17 minus x, what I'm supposed to do is sub in a negative 2, and then I am going to, let's use pink. I'm going to sub in a negative 2, and then I'm going to multiply. So what I have is a negative 2 squared minus 19, and that's going to be times, so that's this part, times 17 minus negative 2. So negative 2 squared is 4 minus 19. And then I'm going to take that as 17 plus 2 is 19. So 4 minus 19 is a negative 15 times 19. Well, 15 times 20 is a negative 300, and that's one too many. So I don't even know. Negative 285. I believe that that's a negative 285. Might be wrong, but whatever. So 15, hang on, I better do it. 15 times 19 is 15 times negative 19. Ooh, look, is negative 285. Okay, so let's do another one. So I have f over g at 0. So again, what does this mean? This literally means that I'm going to take f of 0 over g of 0. So do not panic yet. I don't know if your denominator is going to turn into a 0 or not. So what I have on the top is f of 0. So I'm going to take f of x and shove in a 0. So I get 0 squared minus 10. And on the bottom, I'm going to shove in a 0, which is 8 minus x. So I have 8 minus 0. So 0 squared is 0 minus 10 is negative 10. Over 8 gives me a negative 5/4. So remember, do not multiply your answer by 0. Just shove in a 0 into f, shove a 0 into g, and divide. Okay, so let's move on. Okay, so I want to find all of these things and find the domain. So I have, and this is where I'm going to switch to paper. Why? Because I'm not going to do this all day long. All right, so I've got f of x. F of x is 3x squared minus 4x. And then I've got g of x equals x squared minus x plus 2. Okay? So, and then I'm supposed to give the domain of each one. So I'm supposed to add, subtract, multiply, divide. So, looking at this, hang on, let's go this way. Nope, this way. There we go. Okay, so I'm supposed to do f plus g of x. So let's add these two things together, because remember what that really says is f of x plus g of x. So what is f of x? F of x is 3x squared minus 4x. Plus, what is g of x? X squared minus x plus 2. So now I just need to add. So I've got 3x squareds minus 4x plus x squared minus x plus 2 is going to give me 3x squared and x squared is 4x squareds. Then negative 4x minus another x is a negative 5x, and then a plus 2. So your question is, what's your domain? Assume that your domain is all real numbers unless you see variables and denominators, which I don't, or variables under even roots, which I don't. So your domain is going to be from negative infinity to positive infinity. So let's do f minus, oops, good heavens, f minus g at x. So what does that mean? That means f of x minus g of x. So what is f of x? F of x is 3x squared minus 4x. So I've got 3x squared minus 4x. Then I'm going to subtract g of x. What is g of x? G of x is x squared, minus x plus 2. That's subtraction. Okay? So what do I do with negative? I'm going to change all the signs. So that gives me a 3x squared minus 4x minus x squared plus x minus 2. So what do I have now? 3x squareds minus an x squared is 2x squareds. Negative 4x plus an x is negative 3x. And I got a minus 2. So now I need to know what his domain is. His domain, there's no variables in denominators. There's no variables under even roots. So your domain is once again from negative infinity to positive infinity, which means every number out there is fair game. So now we're going to do f times g at x, which what does that mean? That means f of x times g of x. Good heavens. Times g of x. That didn't need to be there. F of x times g of x. So let me just rewrite that. Why? Because I will need to be more clear. All right. There we go. Okay, so what is f of x? F of x is 3x squared minus 4x. So I have 3x squared minus 4x times, what is g of x? X squared minus x plus 2. X squared minus x plus 2. Okay, so what are we going to do? We're going to distribute. So I'm going to take 3x squared times all those. I'm going to take a negative 4x times all those. And then I'm going to combine like terms. So 3x squared times x squared is 3x to the 4th. 3x squared times negative x is a negative 3x to the 3rd. 3x squared times 2 is 6x squared. So I'm done with this one. Now pull that one through. So a negative 4x times x squared is a negative 4x to the third. A negative 4x times a negative x is a positive 4x squared. And then a negative 4x times a 2 is a negative 8x. And now combine like terms. I get 3x to the fourth minus 7x to the third plus 10x squared minus 8x. And now I need to know what my domain is. Do you see any variables in denominators? No. Do you see any variables under even roots? No. So your domain is all real numbers. And then finally what we're going to do is f over g at x, which is f of x over g of x. So what is f of x? F of x is 3x squared minus 4x. G of x is x squared minus x plus 2. And I'm not going to reduce that, so that's your answer. Okay, so what's your domain? My domain is all real numbers unless I see variables in denominators. Holy cow, I do. So I need to see if this is going to be equal to 0. Okay, so I'm going to say x squared minus x plus 2 cannot be 0. And when I try and factor that, are there two numbers that add up to 2 that would, that multiply to 2, that when I add them together I get negative 1? No, not with the same answer. So here's a little trick. I'm going to use the discriminant, which is the square root part of the quadratic formula. And if that goes negative, then I don't have to do anything else because I can't have a negative under a square root and deal with real numbers. So my answer is going to be 1, because negative 1 times negative 1 is 1, minus 4 times a times c, which means what I have is 1 minus 8 is negative 7. That's not real. It is impossible for my denominator to equal 0. So your domain is all real numbers.